Hello and welcome back everyone. A useful addition for any lathe is a carriage stop. Some lathes come with one fitted standard, while others treat them as an optional extra. My Toolmaster is fitted with a different system of longitudinal stop, which I don't like, so I reckon it's time to make a micro carriage stop. G'day, I'm Steve-O and welcome to the Outback Shed. I have a couple of pieces of cast iron that are 130 by 80. I've already partially machined one block for another project that I later abandoned, and as I can get the bed block out of that piece, I'll use it rather than the unmachined one. I'll need some drawings for this project as there are some critical dimensions. I've confirmed that the V angle on the bed is 90 degrees, and that will make machining of those reference surfaces relatively simple. The micrometer, thimble, rod and anvil will be made from brass, while the plate and clamp will be made from steel. It's been a while since I trammed the vise, so I'll do that and start off with the best accuracy I can get. I'll cut the block to basic shape on the bandsaw. Cast iron cuts well without coolant, and that would only make more mess anyway. I'll machine the faces square and to size with a face mill. This is one that I refurbished a few months ago, and I'll leave a link to that video in the description. No, that's not nail polish, but these bottles are a good way to manage marking out blue. If a bottle gets spilled or broken, there's only 15mm to contend with, and the cap has a brush, so it's very useful. A 16mm carbide end mill and a 36mm end mill cleans out most of the material, but they're not good enough to provide the final surface finish I want, and the 16mm end mill is too short. I found these little Hogger end mills at Mac Pro. They come with 2 carbide inserts on each cutter and they're well priced. I bought a set and a pack of replacement inserts and I'll give them a go. I like these mills, they perform very well. I'm using 30 and 15 degree angle blocks to set the bed block to 45 degree in the vise. However, the reference surface I need to use is the machine surface on the block itself. So I set the angle blocks up on the workpiece using a ruler to negate the round on the corner, and some further adjustment was needed. Yep, that looks fine. I can now mill out the V-groove for the bedway. I'll finish the surfaces with a 20mm end mill, then back to the little hogger to cut the seat for the clamp and finish the bottom edges. First fitting and it looks good. Now I can do the final finishing and put a 2mm chamfer on all edges. I'm using a 45 degree chamfer bit that I bought as part of a $12 set from a local supermarket. Time to make the clamp from an offcut of cold rolled. Again, I'm using the chamfer bit. As the length of the face is more than the cutting length of the bit, I can align the bit by moving it the same distance in both Y and Z directions. This works well for a 45 degree angle. For the second face, I'll remove most of the waste with an end mill before using the chamfer bit to finish the angle. It's amazing what you can do with tools from the special shelf of your local supermarket. I'll clean any burrs with a file and see how it fits. Yep, that's a nice fit. Next I need to cut seats and drill holes to take the 8mm socket head cap screws. The clamp is drilled and tapped to take the clamp screws before the final cleanup of the surface and edges and the test fit. Yep, that works perfectly. The next part is the plate. I'll cut this from a piece of 16mm steel. I reckon this coolness due for a change. Might be a busy day tomorrow. clean up all round and I'll cut the angle to size on the bandsaw, then drill and countersink the holes for the cap screw. Now to make the rod. I'm starting with a piece of 16mm brass and I'll machine it to take a 12 by 1mm thread. changed to a Collet Chuck to provide some protection to the rod when I cut the thread on the other end. Spanner flats are needed to tighten the rod on the plate. I cut these for 7mm Anvil and they'll fit a 12mm open end spanner. Now that's a useful tool. Although the location of the rod is not critical to within microns, it's an opportunity to use the centering tool to bring the punch mark into alignment with the tailstock. The centering tool was the first video I made for YouTube, and so far it's amassed nearly 80,000 views. I'll put a link to it in the description. After drilling and tapping the hole, I'll cut a 15mm relief 1mm deep for the rod to register against. This will ensure the rod is aligned vertical to the plate. Time to make the micrometer thimble. This is machined from a 1-inch piece of brass rod. The target diameter for the knurling is 24.64 millimeters. As I will be engraving the micrometer thimble in the mill with the workpiece held on a divider, the only way to ensure perfect alignment in the divider is to machine the thimble on the lathe in a chuck that can be transferred to the divider. The spindle mount on the lathe is a D13 camlock and the divider is 1.5 by 8 TPI. I made this adapter to allow the divider chucks to fit on the Colchester to ensure concentric turning. I also have an adapter that fits the Toolmaster, and that takes chucks for the BS2 divider. I designed this to use 12 by 1mm threads so that one rotation of the micrometer thimble will advance it 1mm along the rod. It also allows the micrometer to be mounted in the bed block or on the saddle plate. there needs to be relief between the thimble and the rod to prevent binding. Just a few hundredths of a millimetre should be enough, but this can be adjusted if needed. The 10-degree taper provides an angled seat for the engraving. The mill is now centered on the spindle and it's set to the same degree angle that I used on the lathe. This is then checked with a test-dial indicator, as any discrepancy will result in tick marks being of different depth from one end to the other. As adjustments were needed, it shows a difference from the divider scale. This could be a discrepancy in the divider or the Colchester, or a compound error of both. Or I just didn't set it right in the first place. This is the same method of engraving that I used for the fly cutter build. The divider worm drive is a 40:1 ratio, so I'll need to turn the handle 4 full turns between each tick mark. There will be 10 tick marks around the thimble, and as the thread is 1mm pitch, one revolution of the thimble will represent 1mm of travel along the rod, with each tick mark advancing the thimble by 1/10 of a millimetre. The 0 mark is 10mm long, the 0.5 tick mark is 7mm long, and the 0.1 tick marks are 5mm long. The engraving looks good and I'm very happy with it. It's just a matter now of parting off and finishing the end. I rounded over the end with a file, but I did that off camera. The anvil is made with the same 12 by 1mm thread. Spanner flats are also needed to fit a 19mm spanner. Now I can drill and tap the bed block to take the rod. To prevent the thimble moving on the rod during use, I'll put a spring in the end of the thimble to apply pressure between the thimble and the rod. This will ensure constant pressure on the threads, and that will provide enough friction to prevent the thimble from moving during use. It doesn't need much, just enough to prevent slippage. Now the parts are complete, I'll clean up the steel parts and apply a black oxide finish, and I'll paint the cast iron bed block to suit the lathe. The tick marks get a coating of black enamel to provide better visibility. The Colchester has a carriage stop that consists of a bed block and a 5-position turret that mounts to the carriage. Both can be mounted on either side of the carriage. I also have a 5-position turret feed stop for the cross feed. However, I can't mount it since fitting a digital readout. I could mount it on the front of the cross slide, but that would interfere with turning and setting up the taper turner. The Colchester has the advantage of being designed for the carriage and top slide to be power fed into fixed stops. That makes for repeatability and does not pose any risk of damage to the lathe. This lathe comes with a standard 4-position length stop that works by a cam activating a lever to disengage the feed. There are 4 cams that can be set in any position along the length of the lathe. Essentially, the cam is set in the required position to disengage the longitudinal feed when the lathe is under power. I've never used it, and good luck setting it to a tolerance of 1/10 of a millimetre anyway. My previous lathe was a CL460 and it also had one of these. I took it off as I never used it, but that did provide more room to access the swarf tray. The assembled parts look good and blend in very nicely on the lathe. The micrometer and Anvil can be reverse mounted depending on preference. The best way to test the micrometer is to set a dial gauge against the block, then lock the carriage. Winding the micrometer thimble will then advance the block towards the indicator. 1/10 of a millimeter should be enough accuracy for this build, as the lathe is fitted with a digital readout for more precise setting. This has been an interesting and enjoyable build, but since the lathe is not designed to be power fed into a fixed stop, it will get limited use. I think it will be useful for jobs that are undertaken without power feed, and the stop can be used manually to run up to, say, a face or a shoulder. However, we'll see what happens, but I don't want to risk crashing into it under power feed. There seems to be a trend for longer videos lately, and this video could have been uploaded as 2 parts. Please let me know in the comments if you would prefer longer videos for the whole build or to release the build as 2 or more parts. Well, that's it for this project. As always, thanks for watching. I hope you liked this video and enjoyed the build. Please give it a like and subscribe if you haven't already. In the meantime, be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.